Okay, class, picking up where we left off at. We read this example here and we have our equations and we have what the x values are supposed to equal. Now we want to make a table of values for each equation showing 7 solutions for the equation. I took the liberty of going ahead and filling out this information here. Now what you should do is you should just pause this video so you can copy down all of these values. The only thing I did here was whatever the x value was, I substituted in x for these values in these equations. Now, it says B, graph the equation in the same rectangular coordinate system. Set up an appropriate scale on your axis. C, what are the coordinates of the intersection point for the two graphs? What do these coordinates represent in terms of this situation? So we look here at B. The first thing, if we look at the x-axis, x went from 0 to 16. And looking at the x-axis, it looks as though it would be best if we go by 2's. Now, if we look at the first equation, the answer actually went by 5's mainly. So we went from 0 to 50 by 5's, and that will cover all of your y values as well. So I'm plotting all of the points, as you see here. This is for the first equation. This is for the second equation. And I put in red the point where they intersect at, which is 1435. And they ask here, what are the coordinates of the intersection point? It'll be 1435. What do these coordinates represent in terms of this situation? The coordinates represents that if the bridge is only used 14 times, the amount that will be paid for the month will be $35, whether you have the pass or not. So you could say with or without the pass. If the bridge is used $14 times, the monthly amount is $35. And that is the final answer. Now we have a very good description of functions here. And what I would suggest you do is to read all of these bullet points at your leisure. And we will be going over this and the accompanying examples that will follow on the next page. So I would suggest that you read this at your leisure. If you need to pause the video, you can, so you can read all of this. So now we go to the next page. It says here, if f of x is equal to 3x plus 4, find the following values. Now what this means is we have f of negative 2, which means we substitute in negative 2 wherever x appears. So we have f of negative 2 is equal to 3 times negative 2 plus 4. So we have f of negative 2 is equal to 3 times negative 2 is negative 6 plus 4. Negative 6 plus 4 we know is negative 2. So f of negative 2 is negative 2. Now we go here to 0. We take the same function here and we substitute in 0 for x. So we have f of 0 is equal to 3 times 0 plus 4. So f of 0 is equal to 0 plus 4. And f of 0 is 4. Now we go to f of 2. So we will have f of 2 is equal to 3 times 2 plus 4. F of 2 is equal to 6 plus 4. And f of 2 is equal to 10. Now, it says if f of x is equal to x squared plus 4, find the following values. So we do like we did in the last problem. We substitute in these values for x. So we have f of negative 5 is equal to negative 5 squared plus 4. So f of negative 5 is equal to 25 plus 4. So f of negative 5 is equal to 29. Now we go to f of 0 using the same equation. So we have 0 squared plus 4. So f of 0 equals 4. Now we have f of 6 is equal to 6 squared plus 4. F of 6 is equal to 36 plus 4. And f of 6 is equal to 40. Now we scroll on to the next function. So now we still will substitute in these values for x. So we have f of negative 1 is equal to 2 times negative 1 squared plus 3 times negative 1 minus 1. So we have f of negative 1 is equal to negative 1 squared is 1 times 2 is 2. 3 times negative 1 will give us a minus 3 minus 1. So we have f of negative 1 is equal to 2 minus 3 is negative 1 minus 1. And f of negative 1 is negative 2. Now we have f of 0. So we will substitute in 0 in this equation. So we have 2 times 0 squared plus 3 times 0 minus 1. So we have f of 0. 0 squared is 0 times 2 is 0. 3 times 0 is 0 minus 1. So f of 0 is equal to negative 1. Now we will have f of 3 is equal to 2 times 3 squared plus 3 times 3 minus 1. So f of 3 is equal to 2 times 9 plus 9 minus 1. So we have f of 3 is equal to 2 times 9 is 18 plus 9 minus 1. So f of 3 equals 27 minus 1. And f of 3 equals 26. Now, we come to the next example. This time again, we substitute in these values for x. So we have f of negative 3 equal to negative 3 cubed minus 2 times negative 3 squared plus 5. So we have f of negative 3 is equal to negative 3 cubed, negative 27. Negative 3 squared is 9 times the negative 2 is negative 18 plus 5. So f of negative 3 is equal to negative 40. Now we come here. We substitute in 0. So we have f of 0 is equal to 0 cubed minus 2 times 0 squared plus 5. So we have f of 0 equals 0 cubed is 0. 0 squared is 0 times a negative 2, give us minus 0 plus 5. So we have f of 0 is equal to 0 minus 0 plus 5, which is 5. Now we come to the last part. We have f of 1 is equal to 1 cubed minus 2 times 1 squared plus 5. So f of 1 is equal to 1. 1 squared is 1 times negative 2 is minus 2 plus 5. So 1 minus 2 is negative 1 plus 5. So f of 1 is equal to 4. Now we scroll down. It says in the previous examples, what did you observe each time you found f of 0? That the value without x was the answer. What could this possibly mean or relate to? This relates to multiplying by 0 and adding or subtracting to 0. An application of functions using function notation. The wage gap is used to compare the status of women's earnings relative to men's. The wage gap is expressed as a percent and is calculated by dividing the median or middlemost annual earnings for women by the median annual earnings for men. The line graph shows the wage gap for selected years from 1960 through 2003. A. Use the graph to estimate to the nearest percent women's earnings as a percentage of men's in 2003. You look here at 2003, it's approximately 76%. You could write 75 or 76%. The function f of x is equal to 0.012x squared minus 0.16x plus 60 models the median women's earnings as a percentage of men's earnings. F of x years after 1960. Use this function to find women's earnings as a percentage of men's in 2003. Round to the nearest tenth of a percent. Now I took the liberty of filling out this problem here. What we need to do is this. These are all the years after 1960, and we're going to 2003. So the difference from 2003 and 1960 is 43 years. So that will replace your x values here. So we will substitute in 43 for all of our x values, and we would end up with these amounts: 22.188 minus 6.88 plus 60. And after we combine these values, we will end up with 75.308, and it asks us to round to the nearest tenth of a percent, so we'll round to the tenths place, so it'll be 75.3, which is very close to the 76% or 75% that we got for A. Now we have our next example. It says graph the function f of x equals 2x and g of x equals 2x plus 4 in the same rectangular coordinate system. Select integers for x. For negative 2 is less than or equal to x, which is less than or equal to 2. For each function, we make a t-table to display the coordinates. Now, next we're going to plot the 5 points for each function and connect them. And then we're going to determine the relationship between the two graphs. Now, you have the example listed here. Now, if you notice, with this inequality here, if you notice, this includes negative 2 to 2. So it'll be negative 2, negative 1, 0, 1, and 2, which we have here. And what ended up happening with these functions, we substituted in these values for the functions and received our answers and got our ordered pairs here, as you can see. Now you could pause this and write down this information, or you could just follow along in your course pack. Now the graph. Graph all of these points here. And what we notice here, it says, do you see a relationship between the two graphs? You notice the two graphs will never touch. And if you notice, both of these graphs are set up where the value in front of x is 2. Now it says, do you see a relationship between the two graphs? It says they are parallel and have the same slope. Remember this, y equals mx plus b. F of x, g of x, and all of x's with a function represents y. So the number in front of x is your slope. Remember from Math 20, if your slope is the same, then your lines are parallel. And this is the relationship between the two graphs.